Hi everyone, welcome back, and this is the next of our translation videos. We're going to talk about horizontal stretch and compression. So like before, let's look at our statement here and talk about it very briefly. We're going to let f of x be any function as before, and now what we're going to do is we're going to multiply the domain element by a number first before applying the function, and this has the effect of stretching or compressing in the horizontal direction. But this time, instead of multiplying y coordinates by a, we're going to multiply x coordinates by 1 over a. And then note, again, we have the same conditions on a because we want things to be positive, because if we start throwing in negatives, then we're going to start dealing with reflections, and we want to keep that a separate issue. And a equals 1 doesn't change anything. So let's look at our first graph. So this will be f of x equals square root of 3x. So I am going to draw a pretty decent size graph here. And I want to choose 3 by 3 squares to be 1. So here is 0, 0 at the origin. So if I go over 3 up 1, this will be 1, 1. And then let me see. Oh, sorry, I skipped a step. Well, I'm doing it, but I forgot to tell you we're graphing g of x equals square root of x first, just like we would always do. So at 4, we will be at 2. So here's 2, 3, 4, 1, 2. So here's the point 2, 4. And we will let it keep going like that. And there we go. So let's see what happens when we let f of x equals the square root of 3x, which now is just g of 3x. It's just a composition. So again, we're going to draw our nice big graph, and we're going to keep the scale this time. So again, this is 1, and this is 1. So we're going to multiply all the x coordinates by a third. And so 0, 0 becomes 0, 0. But notice that 1, 1 now becomes a third 1. So that will be right here. And then here, oh, I wrote this backwards. This should be 4, 2. So 4, 2 will be at 4 thirds. So 4 thirds will be right here, and then 2 will be up here. So this is 4 thirds 2. And then I didn't draw it up here, but there's a point way out here, 9, 3, which we can change to 3, 3. So let's see, there's 2, there's 3, there is 2, and so this point is also on the graph. And then we draw, and notice that we compressed the graph horizontally. Alright, very good. So let's look at our other example. We're going to graph the square root of 1/2 x. So again, we're going to start off with our graph g of x equals square root of x, but this time we're going to let a 2 by 2 grid be 1, so this will be 1, and this will be 1. And so notice that I'm letting the fractions, or what we're multiplying x by, determine the size where I'm putting my scale at here. So again, we'll have 0, 0. We'll have 1, 1. We'll have 2, 3, 4, 2. And let's extend this out just a little bit more so we can get 9, 3 in here. So 5, 6, 7, 8, 9, 2. Here we go. 9, 3. So now we're going to cut everything in half and look at f of x equals the square root of 1/2 x, which is just g of 1/2 x. So that implies that we just have to multiply all these x coordinates by 1/2, and we'll get it to work. So again, scale is 1, 1. And so 0, 0 will just go to itself. But notice that, I'm sorry, I said multiply by half. I mean multiply by 2. Because remember, we're multiplying by 1 over a. So multiply by 2 and multiply by 2. So we're not going to graph this point, but we'll graph the other ones. So this will be, so 0, 0 just becomes 0, 0. So 1, 1 will become 2, 1. And then 4, 2 will become 8, 2. So let me see, that's 2, 3, 4, 5, 6, 7, 8. And 2 here. And notice that we are getting a badly drawn graph. So let's try again. And so notice that we are getting a horizontal stretch here. Alright. So we have one more type of translation to do, which are reflections, and we will see you for that video.